We started off talking last time about instantaneous power. And in particular, we said that this is the formula. And if you really understand all the implications of this formula, you're free to check out for the rest of this exam block. It really all comes from this. If it's a sinusoid, then P of t is composed of two parts. It's composed of something that's at a sinusoid part that's at 2 times the frequency of the input current and voltage. And it is also composed of a DC part. And you'll remember there's a 1/2, looks like 1/2 of the DC part plus this cosine at twice of the input frequency. And then there's the 2 pi t part with possibly theta. But the important parts to realize is this: twice the frequency and the DC part multiplied by 1/2. Okay. And then the third part is that in general, P of t is not equal to 0 across resistors, capacitors, and inductors. And it is always a function of time. It's not just a number. It's a waveform that's changing. Now, compare that with average power. So last class, we said that it's always equal to 1 over. Firstly, it only makes sense to talk about an average power of a repetitive, a periodic waveform. And we'll say of period t. So every t seconds, it duplicates itself. It only makes sense to have an average power of a periodic waveform because if it's fundamentally not a periodic waveform, it changes depending upon what period of time we're looking at it. But if it's a periodic waveform, then if we take the integral over one period and divide it by that period of P of t dt, then we'll find it. And so it's a number. It's not a function of time. And this equation right here, this equation works for any waveform. It does not have to be sinusoidal. But for sinusoids, which is the one we'll be working with the most, this average power is equal to 1/2 V maximum, that's supposed to be a M, I maximum, times cosine of the difference between the current and voltage phase, where if we want to use phasors, we can take the real part of, here's our phasor in bold, times our phasor in bold. So these guys aren't phasors. These guys are numbers, right? When we're talking about sinusoids, we're saying something like a voltage of t is equal to V max times cosine of omega t plus theta v. And we could represent that if we wanted to as a phasor in bold like this. So the phasor is a complex number. All right, so these were also important things to to know. And of course, these are true only for sinusoids. And the very last thing is that for average power is that in general, P average for capacitors and inductors will equal, let's see, what do you say, Will? What's the average power over a period for a capacitor or an inductor?
0, right?
Absolutely. 0 watts. And for a resistor, what can you tell me about that, Dantre?
Would it be
or are there any limits on
that
it?
It can't equal less than 0?
Exactly. That's exactly right. It's always got to be positive. I guess it could conceivably be 0 if your whole circuit is turned off, but it cannot be negative. All right. So these are also true for any waveform. All right, that was a lot of details. Let's move on to our new material for today.